Hello everyone, my name is Ali Shamakhi and this talk is about supporting strings in JayHorn. This is joint work with Hossein Hojjat and Philip Romer. JayHorn is a software model checking tool for Java that gets an intermediate representation of Java bytecode of the program and models it using horn clauses. An underlying model checker like Eldarica will check the satisfiability of these horn clauses. You can find a general description of JayHorn architecture in the JayHorn paper at TechAS 2019. We use algebraic data types or ADTs to model strings in JayHorn since horn solvers do not yet support strings natively. You can see our other paper on strings in software model checking for more background details. The string ADT is defined using two constructors, nil with no argument and cons with a character and a string argument. As you can see here, the ADT representation of a string can be left to right or right to left. So how can we model an operation using horn clauses? The compare to is an interesting example to illustrate. It compares two strings lexicographically and returns an integer value. If they have different characters at one or more index positions, the return value will be the difference of their characters at the smallest index of such positions. Otherwise, it will be the difference of the lengths of the strings. We start with the left to right recursive encoding of compare to. Here, the first two arguments of the predicate P are strings to be compared, and the third one is their comparison result. The first three horn clauses are obvious cases where one of the strings is nil or both are the same. The fourth horn clause says if we prepend different characters to any two strings, the result will be the difference of those characters. And the last horn clause is saying the comparison result of two different strings will remain the same by prepending the same character to them. The right to left encoding is more complicated, since we need to track the source of the comparison result according to the definition of compare to. Here, another argument in the predicate indicates whether the result is based on a character difference. The first three horn clauses are the same as before, except that the fourth argument is false, meaning the comparison result is a length difference. That argument being false also means that one of the strings is a prefix of another. The next two horn clauses say, if that is the case, we can append the character to the non-shorter string and the result will be accordingly increased or decreased by 1. Note that adding a character using the constructor cons will append it to the end of the string in the right to left encoding. Here the next horn clause shows that appending different characters to strings that are equal brings us to the character difference case, where the comparison result is their difference. In this case, appending any character to any of the strings does not change the result, as demonstrated by the last two horn clauses. JayHorn supports some basic string operations now, but it is not supporting more complicated operations related to substrings and regex matches. In svcomp, it solved 6 out of 53 string benchmarks. In this table, you can see JayHorn results using different encoding choices. In general, right to left is performing better than left to right, probably because appending characters is more common than prepending. And under-approximating outperforms over-approximating, maybe due to loss of information about string content during over-approximation. Other encoding choices had no significant impact on the results. Thank you.